that it's up and running. Okay, it looks like we're running. Hi, y'all. This is Jeff. I'm here. Would you like to introduce yourself?
Hi, I'm Maria.
Maria and I worked together. When was it? Could you remind me and the audience when we worked together and what we were doing?
Winter quarter 2021, I took linear algebra, and then in the spring, I came back as a TA and to do an independent study.
Yeah, I think that was Math 2B at Foothill College. Today, I'm hoping to capture your voice and your experiences. One, to highlight some of the great work that you did in our class, and then two, to help future students who take Math 2B get accustomed to the structure of my class and kind of some of the unique features. And so I might start by just kind of asking you what your initial reactions were in our class. I used a flipped classroom model, and also I do some really interesting thing with grading. And so I wonder if you might just talk about what it was first like to be in my class that first week or two. What came up for you as you were trying to survive?
At first, my first reaction to the flipped model was excitement, but I was a bit concerned that I would not be able to keep up the motivation to consistently watch the videos without the added pressure of graded homework and exams. But then when I heard about the portfolio, those fears went away, because instead of relying on punishment motivation from exams, the portfolio is much more intrinsically motivated, and I would study not because I didn't want to fail, but because I wanted to learn. So yes.
That's really exciting. That's the whole goal of this, is to empower students to be curious and to actually engage with learning authentically at your own pace, right? Like not having to be paced by the teacher, but you can pause and rewind. And if the week is crazy, you can put it off until the weekend and stuff like this. So I'm happy to hear that that worked out for you. I wonder if you might talk about what you did in your portfolio. So specifically, what was your project like? You kind of determined your own learning. And what did that look like in your mind?
So my project was to write my own linear algebra textbook, and it came in phases. I started off just copying down what was in the lecture videos, wasn't incredibly effective. And then I moved on and I improved on that method, trying to build a deeper understanding. I tried to gain some intuition for proofwriting and some applied projects. So yes, I learned how to write a textbook, and I still use that method today.
I'd love to talk more about that method and what you learned, because I think it's an extremely powerful thing. One thing that I want to highlight here as we're talking is the idea that you first tried something, reflected on what you were trying, and then improved it as time went on. I find that to be a really powerful way to judge somebody's work in the class, that the work that they do in week 12 looks very different than the work that they did in week 1. And I think that's true for you, right, is what you're saying. I wonder if you would show some of the work that you produced and kind of talk us through what you did, what you changed, what you learned, how it affected, blah, blah, blah.
Definitely. I will share my screen.
Yay, lava.
So here, I will start with some of the first notes I took. So this is for lesson 2. This is when I was just copying down what was in the lecture videos. It isn't terrible. I think I had the right idea. I tried my best to make it exciting looking. However, it is a bit difficult to read, and it doesn't have a lot of original thought, but that is fine because improvement is everything. And then from here, the next phase was in lesson 5, when I first tried to understand the material deeply for the first time. I think in lesson 5, there was the law of cosines proof, the Pythagorean theorem, and the triangle inequality. And I tried my very hardest to understand what was going on so that I could reproduce it on my own. And I still at this point not really writing my textbook legibly. It is a bit hard to read and decipher, but that's fine.
Can I highlight one thing that I see that you changed between those that I think is awesome? And I actually remember talking to you about this when you did it. One thing I see that you changed is that you spread out your work a little bit so that one horizontal section of the page contains only one idea, even if you're writing on like little side notes. And then I love what you're saying, that transition that you made in your mind. And I remember having this conversation with you because you took it really seriously, which is so many students come into my class thinking that, or really having only one experience, which is they write down exactly what the teacher says and only what the teacher says and nothing more. And I think the reason that they do that is because in an in-class lecture, there's not time to do anything else, right? Mm-hmm. And so that's the only skill that the student has generated before we've met each other. Just copy everything the teacher says. I don't know if I understand it or not. That's it. And I remember we talked through that. And one of the things that we developed that you actually implemented this, and I see some of it. I see it in the way that you structure your work and the way that you're organizing it. I see it in the comments that you wrote. You really started to take intellectual ownership over the ideas that you were writing, so that it wasn't the stuff that I wrote that you captured. It was the stuff that came up in your own mind. And I remember in your portfolio, often you would write more than I had written on the board, and you would start to customize your notes. And I wondered if you kind of wanted to talk about that transition and what that looked like, or any insights into that, knowing that future students are going to struggle with that same thing, right?
Wi-Fi was having some problems.
Oh no, that's okay. I see you. I see you. Can you hear me?
Yes, I can.
Yeah, I wonder, we're doing the best we can with Zoom. The point is, I wonder if you could kind of talk through that transition of copying everything that I wrote into starting to create your own notes, and what are some of the ways that you thought about that?
Well, I wanted something that I could be proud of, and it wasn't really satisfying to be able to copy down lecture notes. That doesn't require any deep thought. You can't finish the day and think, I did great work today. No, I just write down words. And I think the mindset shifted when I realized that I would have to prove things in the future, even if I didn't do linear algebra ever again. And I wanted to learn how to organize my thoughts logically and clearly.
Awesome. Yeah, I love it. I absolutely love it. I wonder if you just keep kind of talking us through as you progressed. I know you have your portfolio up and running. I'd love to just keep talking to us. Show us what you did and what came up for you and some of the progressions.
And then the next phase was by lesson 10, I started thinking that maybe I want to read these notes again. And so I started to make them more legible. And I also started this thing where I leave comments on anything that I think that in the future I would find confusing. And this is very good in the moment for the learning process because it requires a lot of thought to be able to anticipate what is and isn't relevant and what may be confusing. And this is also good because I stopped leaving thoughts and explanations incomplete, thinking, oh yeah, whatever, I'll remember it later. And yes, so this is lesson 10. It looks aesthetically much better than the previous one. And it is also more organized. There were more comments. I am understanding much more of what I'm writing down. And there was the spring mass system. And I put a lot of effort into actually understanding this and some of the physics behind it. And yes. And then I knew that I understood it well because when I would do some practice problems with the spring mass chain system, I had very little issue doing them. So yes.
I wonder, one thing that comes up that I think is kind of a surprise for many of my young students who are taking my class for the first time is the time commitment that it takes. Because in-class lectures have a set end time, going through a 2-hour lecture costs 2 hours because it's live in class, right? Whereas when you're doing the kind of work that you're doing, one thing that I would ask is how often would you pause? And also, how would you actually engage with this? What, you know, eventually I'd love to get to the answer to the question, for 2 hours of videos, how long would it take you to produce the corresponding notes? But before we get to that question, I think just kind of walk us through how you would take advantage of the videos and then actually translate that into the notes that we see here.
I would pause the videos every few seconds to write things down and to try to guess what was coming next. And it took a lot of time. It was very time consuming, but I didn't really mind because I thought it was fun. And how long it took for a 2-hour video to write down the notes, maybe 5 hours, quite a long time.
That to me sounds pretty accurate, given what I see that you produced. For me, I always like to say that 2 hours of in-class notes would take me about 6 hours of work, 5 to 6 hours, because I always had a 1 to 4 ratio. 1 hour of lecture is 4 hours outside of class. And like 2.5 to 3 of those hours were understanding what was written. And then the other like hour and a half was all about translating what my understanding was to solving practice problems, right? And so I love the fact that you did that. And I just wanted to call out that I think you had color codes, didn't you?
Kind of. I think orange is for comments and white is for content, so it doesn't get muddled.
I love it. And that relates to the idea of like abuelita language and notation and formal mathematics, that you're adding on top of the notation your own understanding and really making this your own. You're creating your own knowledge in that way, right?
Yeah.
Awesome. Yeah, keep going. Keep talking us through. This is absolutely beautiful, Maria. Thank you so much for highlighting this.
And then the next phase is when the material got a lot more abstract and it moved on from more applied examples like the spring mass chain system to things like the invertible matrix theorem. And it is here where I started trying to practice getting familiar with proofs. So before I would see the proof from the textbook, I would try to build intuition and try to kind of write a semi-rigorous proof myself. And then I would copy down the official proof and try to understand it the best I can. And let's see. And yeah, I started thinking more deeply about abstract concepts. For example, this one with the homogeneous linear systems problem has only the trivial solution. When I wrote this down, I was pretty confused about why that meant that it would be 1-to-1. And then this concept actually came back later in my abstract algebra class, where we learned that if you have a homomorphism and the kernel only has the identity, then the map is injective. And I was like, oh, wait, I remember this from linear algebra. And so information builds, and that is great.
Yeah, it's one of the biggest, one of the ways that I like to help my students reclaim their humanity in my classes is to focus on building their knowledge as part of a larger structure. So often when I center exams in my classes, students will work really, really hard to get through the exam and put no thought into the learning for their future selves. Whereas one of the major goals of the portfolio process is to help each of my students build knowledge that if in the future they want to refer back to, they have, for you, I think probably hundreds of pages of work in your own customized textbook that is really designed for you, right? And what you're saying is that you've actually found that to be useful.
Yes.
Yeah, I want to hear more about that. I don't want to stop you from kind of highlighting the different stages of your portfolio, but at some point, as we get towards the end of this interview, I'd love you to talk about how this structure has related to the work that you're doing up at Davis now.
Mm-hmm. And then the next stage after that was the LANA Project. And I see that I did not remember to download the notes for that. Nevertheless, it was an applied project where we we used the concept of non-singular linear systems problems to solve for the electrical behavior of a circuit. And this is very exciting because I knew nothing about electrical engineering or circuits or anything like that, but I was still able to come up with the answer at the end, and then even to write my own C++ program to do the calculations for me. And that was a great intersection of computer science and math. Yeah.
Yeah, that was super exciting. You actually broke down the walls between your classes and that you started to build intersectionality between what you were learning in math and what you were learning in CS. And I think you even made your own GitHub item on that one, didn't you?
I did.
Yeah. I wonder if you could show lesson 18. I saw some, or just 17 or 16, any of those lessons. LU factorization lesson 15 would be awesome. Did you continue to use timestamps? I know we had talked about that, but I don't remember if you found that particularly useful.
I actually timestamped using an app called Clocky, where yes. So every time I work on something, I just click this button and it counts. And I try my best to leave a comment to describe what I did, but usually I get lazy. But it is really good for managing my time.
Yeah, so I wonder, I don't know if it's, I saw it in one of your previous notes. Can you just scroll down to the bottom of these pages? Yeah, there we go. Can you kind of talk about that just so that folks kind of understand what you're doing there?
The timestamping?
Yeah.
Yes. So I started timestamping because I had a massive problem with spending way too much time ruminating on a concept I didn't understand and going in circles. And at some point, that rumination becomes unproductive. So I would have to cap that time and say, I have only 10 minutes to understand this. If I don't understand after that, I have to take a break and come back. And at first, it was very difficult to pull myself away from studying and force myself to take a break, but I found that it has been incredibly helpful. Yes.
Yeah, that habit, I'm going to work with all future students on that process of one, tracking your time so you can be focused during bouts and you really stay focused and you don't go down that rabbit hole. Two, so that you're sure to take breaks. And then three, that you can put caps on stuff so that you don't kind of cycle into despair, right? And I really appreciated one of the things that I saw over and over and over again was that you tried these new techniques to improve your studying and that you would implement that on the future. So by the time you got to lesson 18 and even into LANA, you were successfully leveraging a ton of new study techniques that that were different from what you were doing at the start. And I saw that it was increasing your efficiency. So you were doing more work in less time. And it was also increasing the depth at which you worked. Your work was a way higher level. And I wonder if you wanted to talk about some of those changes. One, what are some takeaways that you got from this class? Two, how have you used those in your future? So that, how did what you learned in this class, not only the math, but the skills, translate to the next stage of your career?
Basically, I learned the skills that I needed to tackle very hard concepts in a shorter amount of time. Previously, when I would see something difficult in my classes, I would usually despair, thinking there's no way that I'm ever going to understand this thing. If I didn't understand it immediately, I thought I was pretty much screwed. Now I have a ton more confidence because I know how to approach a problem and how to take notes and how to manage my time effectively in order to get over those hurdles and actually succeed.
Do you want to talk a little bit about what that looks like now that, can I say where you're at right now? I don't know if you want to tell, you went from Foothill College to...
Yes, I transferred to UC Davis, and this is my first year. Yeah.
Yay. And I think you're doing a double major in CS and math, or maybe...
I haven't decided on the math to CS ratio that I want yet. Currently, I'm a computer science major, but I'm mostly taking math classes. I'll see where that goes.
I wish I could just pay for your tuition so you could do your double major and not worry about funding. Do you want to talk a little bit about how you've taken the idea of a portfolio in this class and extended it to the work that you're doing up in Davis and what impact that has had on your studies?
Definitely. I now try to have a portfolio, a written textbook for every single class that I take. And it has become almost like a hobby. And it has completely changed my mindset around studying. Now I don't go to lecture thinking I need to go to lecture, understand everything that is going on and study so that I don't fail and I don't end up in a ditch and die. Now I think I lecture so I can find out what I need to know, and then I can come back home and then a few hours later contribute to my textbook. And I love writing textbooks for my classes. I just finished an abstract algebra course, and I wrote a very nice textbook in my opinion. And here it is. Some of the highlights of this is, one, it is very aesthetically pleasing.
Oh my goodness.
I put some art into it. Yes. And
that looks like
I
permutation groups.
Oh yeah.
Yeah.
They're somewhere here. Yes. Basically, I wrote this one more cohesively. I use more words. I use the royal we to kind of mimic how real textbooks are written. And I make sure to reprove every single theorem that we see in class. So this textbook has a lot more proofs than the older ones. And one more thing that I added that I did not have before, but was very helpful, is this. My list of misconceptions.
Awesome.
I do this right before midterms and finals. So I write a misconception I had, why it's easy to make the mistake, a counterexample, and what I should have said instead.
Whoa.
Yep.
I love it. 126 pages. And you got, the cool thing is, like, one thing that I really love about this, and this is why I'm so serious about my students, is it means that every quarter you're producing work that is yours forever. And instead of having to go to some other author's textbook, you can go to your own work and learn from yourself, basically. So you can teach yourself 10 years from now ideas that you studied today, right?
Yeah.
I thank you so much for this, Maria, for highlighting your work. And I'm so happy for you. I wonder if you wanted to just give some words of advice and some coaching. One thing that's really funny about being a community college teacher is I get to work. I like to say that you are the best and the brightest in the nation. I actually think my students are as good, if not a little better, than MIT, Stanford, UC Berkeley. Not only because you all are literally the brightest in the nation, you're hardworking, but you're getting a better education for cheaper, right?
Yeah.
Yeah, and it's just such a pleasure. But one thing that's challenging is that, after you graduate, you go on to great things, and then my next generation of students don't actually get to hear your voices and don't get to hear the amazing stories and all the power. And right now we're kind of changing that in this interview. And I wonder if you wanted to give some coaching to, knowing the structure of my class and knowing how different it is and what it meant for you, maybe any words of wisdom or just ideas that you think maybe that next generation would benefit from.
Sure. I think the most important thing is to stop measuring your intelligence and your self-worth by your math grades. For some reason, math has this reputation as you have to be naturally good at it, naturally gifted, and that there's such thing as a math person and not a math person. And if you don't get something quickly and naturally and intuitively, then you're not a math person and you should just give up. And not any other subject has this problem, just math. And I think that should change. I think people's mindsets should change about that. And they should stop, closing off the idea of studying math just because they're not a math person, haven't done well in the past. And I think that people should take advantage of this opportunity in this linear algebra class where there aren't traditional grades and there is more freedom to take advantage of this, not write it off as an easy A, and try to build skills that will be helpful in the future. And even if they never do linear algebra ever again, and it is not relevant to their career, learning how to learn is relevant and it'll be helpful for everybody.
Thank you so much. I'm right with you on that. I take this really seriously. I believe in my students. I think you are a genius. I think you literally make mathematics better when you're a part of this. I have this mask that I bought for COVID that says how to be a math person, do math, any type, and be a person. Right? And I agree wholeheartedly. Maria, I thank you so much for your time and for sharing your expertise and your wisdom. And I cannot wait to see all the great things you do. Now I have an official record that I know you, so that when you go famous, I can claim. So I'm going to go ahead and stop this interview. Thank you, Maria.